Welcome, everyone. We're going on an adventure into the world of data mining and machine learning. And yes, I promise there will be some fun metaphors along the way. Think detectives, gold miners, and maybe even a wise Yoda reference. So buckle up because we're about to dig for gold in the digital jungle. So, what exactly is data mining? Picture your computer as a caffeinated detective. Like Sherlock Holmes after 3 espressos, sifting through mountains of clues. On the mundane side, it's deciding if that email from a Nigerian prince should hit your spam folder. On the magnificent side, it's Netflix knowing you'll binge that new crime documentary before you do. Slightly creepy, maybe. Incredibly useful, absolutely. Here's a reality check. People love saying we're in the information age. That's adorable. We're not just surrounded by information anymore, we're drowning in it. Every swipe, click, purchase, and selfie adds to this tsunami. Businesses, scientists, hospitals, social media. Everyone's generating data faster than we can say petabyte. If data were physical, Earth would have collapsed under its own weight by now. Good thing it's just ones and zeros. Now here's why we call it mining. Just like miners dig through tons of dirt to find tiny gold nuggets, data miners dig through terabytes of digital noise to find precious insights. Sure, knowledge discovery from data would be more technically accurate, but that sounds like something from a philosophy textbook. Data mining is catchy, marketable, and frankly way more fun to say at parties. Not that I talk about data mining at parties. Okay, sometimes I do. Let's talk about the complete journey. KDD, or knowledge discovery from data. Think of it like a well-organized heist movie. First, you prep your data, clean it up, integrate different sources, transform it into something useful. Then comes the action sequence, actual mining where algorithms do their magic. Next, we evaluate. Because not every pattern is a winner. Some are just random coincidences like ice cream sales correlating with shark attacks. Finally, we present our findings, ideally in one slide that makes your boss say, wow. Remember, KDD is the journey, data mining is the adventure, and knowledge is the treasure. Before we dive deeper, let's understand what we're actually working with. Datasets have two key components, samples and features. Samples are objects in the real world. Customers, transactions, products, cats on the internet. Features are how we describe them. Age, purchase amount, number of legs, fluffiness level. Getting the right features is half the battle. As you can see in this customer example, we're tracking purchases and spending to classify value. Simple? Yes. Powerful? Absolutely. Now, for the three genres of analytics, and yes, I'm calling them genres because this is basically the data science equivalent of movies. Descriptive analytics is like a documentary. What happened? It tells you that high-value customers love weekend discounts. Predictive analytics is the thriller. What's coming next? It forecasts who's about to churn. And prescriptive analytics? That's your GPS. It doesn't just predict, it tells you, send this person a 20% discount, 65% chance they'll convert. We've gone from showing what happened to guiding what to do. If data mining were a superhero movie, statistics would be Yoda, the wise mentor teaching our hero how to think. Statistics helps us collect, analyze, and interpret data. It's the science of figuring out if the numbers are telling the truth or just messing with us. Here's the catch though. Classic statistical methods can be slow when dealing with big data, like trying to run a marathon in hiking boots. That's why data mining researchers developed faster, distributed algorithms. Same brainpower, optimized for speed. Think of it as teaching a mathematician to sprint. Meet the ambitious younger sibling, machine learning. While statistics is the mentor and data mining is the action hero, ML is that curious kid who learns from experience. No explicit instructions required. Why does it matter? Because it scales decision making. Humans get tired after 100 spreadsheets. Machines, they'll analyze 1,000,000 and still be ready for coffee. Together, statistics gives us theory, data mining gives us tools, and machine learning gives us adaptability. It's the holy trinity of data-driven decisions. Now let's talk about adaptive systems. These aren't your grandfather's machines that follow rigid instructions. These systems change based on feedback. Think about your GPS app rerouting you when traffic changes. That's not magic. That's adaptation in real time. The key is the feedback loop. Receive data, adjust parameters, improve responses. Like good employees, these systems take feedback, adjust, and get better every day. Though unlike employees, they never complain about the coffee machine being broken. Supervised learning is the teacher-led approach. Every input comes with the right answer attached, like having a personal tutor. The model makes a guess, compares it to reality, measures the error, and adjusts. Repeat until smart. We have two main flavors. Regression predicts numbers, like customer spend, and classification predicts categories, like high value versus low value, but watch out for overfitting. That's when your model memorizes the textbook but fails the exam. The goal is to learn enough to be good, but stay flexible enough for surprises. Unsupervised learning is exploration mode. No labels, no teacher, just data and curiosity. The machine figures things out on its own, spotting similarities and forming clusters. Think about it. You give it customer data, and it discovers natural groups. Loyal high spenders, occasional browsers, one-time shoppers. The mantra is simple. Put similar things together, keep different things apart, and don't panic if something doesn't fit neatly anywhere. Like exploring uncharted territory with a compass, adventure awaits. We have two more learning approaches worth knowing. Semi-supervised is the clever hybrid. You have mountains of unlabeled data, but only a few labeled examples. Use those few labels as anchors to guide everything else. Here are a few examples. Now go figure out the rest. Smart, efficient, practical. Then there's reinforcement learning. Learning by trial and error. No teacher with gold stars, just rewards and penalties from the environment. It's how systems learn to play games, optimize prices, and personalize marketing, just like humans. Try, fail, adjust, improve, repeat forever. The deep learning revolution. It started in 1957 with a simple perceptron, a basic artificial neuron. For decades, progress crawled because computers were weak and data was scarce. Then boom, cheap GPUs, oceans of data, and neural architectures inspired by the brain. These models learn through repetition, adapting like living organisms. They power image recognition, speech assistance, autonomous vehicles, and so much more. The key insight? Sometimes being approximately right fast beats being precisely right late. In nature and business, adaptability wins. When ML met big data, it was love at first terabyte. Suddenly, we could process massive datasets at lightning speed. Think about the scale. 1 million customers times 1,000 products equals 1 billion relationships. Monumental for one machine, trivial for distributed systems. This unlocks recommendation engines at Netflix, image recognition at Google, and collaborative filtering everywhere. Let's recap our journey. Data mining is gold mining, extracting insights from digital mountains. KDD is the complete pipeline from prep to presentation. Analytics comes in three flavors: descriptive, predictive, and prescriptive. Learning has multiple paradigms: supervised, unsupervised, and reinforcement. Statistics, data mining, and machine learning form the holy trinity. And deep learning plus big data equals the AI renaissance we're living through. We've officially left gut feelings territory and entered show me the data land. And that's our journey through the digital jungle. Thank you for your attention. Remember the big idea: our machines are no longer just extensions of our hands. They're extensions of our minds. They don't just help us work faster, they help us think better.